All right. So thank you, everyone. I know some of you joined on the Meet and as well as the live stream, so I encourage everyone to be on mute, please. Thank you very much. So first of all, I would like to welcome all of you to the Google Lunch and Learn. My name is Ingrid Gonzalez, and I'm the Google Cloud Sales Director based out of New York. So on behalf of the Google Cloud family, I would like to thank all of you for joining us and giving us some of your time. I hope that every one of you, including your family, your loved ones, and your colleagues are doing well in this challenging period. This Lunch and Learn is part of the weekly series, and our goal is to engage with our customer and serve you better. We are a big believer in open source technology, and as the original designer of Kubernetes, we have a wealth of knowledge on this topic that we would like to share with you today. At the end of the session, we'll have time for questions. So please, I encourage all of you to type your question right now on the live stream on the YouTube Live, and Sandeep will address them at the end of the talk today. Now, I would love to introduce you all to our speaker, Sandeep Parikh. Sandeep leads the Anthos developer advocacy team at Google Cloud, where he helps customers to adopt cloud technology like Kubernetes, Istio, and Knative. His team developed reference architecture, white paper, and code for practitioners to use when modernizing their application platform. During the presentation, Sandeep will discuss Kubernetes best practices in the enterprise environment. So Sandeep, without waiting, you have the floor. Thank you, everyone.
Great, thank you, Ingrid. Welcome, everyone, to this Kubernetes Lunch and Learn. Today, what I wanted to talk to you about is bringing Kubernetes into the enterprise and what that really takes and how it fits in. Kubernetes as a technology has been around for several years now. We've certainly hit major milestones with reaching sort of 1.0 back in, I think, 2015 now, so about 5 years ago, all the way to today, and number of releases, a huge drive in the ecosystem and the community around Kubernetes, and a good sort of bit of functionality and features around how do we do Kubernetes in the enterprise, and what are some of the lessons we've learned, and how do we apply those moving forward. So the topics I want to cover today are a little bit of background around what is Kubernetes native, what does that really mean as it relates, again, to enterprise workloads, how do we package and deliver enterprise workloads into Kubernetes environments, what does it look like with services, right? How do we manage, how do we deploy and develop new services? And then how do we enforce guardrails? How do we keep things running as smoothly as we expect to? How do we maintain sort of IT governance infrastructure and rules around that? How do we define and enforce those sorts of policies and guardrails? And then I want to close with a little bit of how does this all look in a hybrid and multi-cloud world, right? Because that's the reality of the world we live in today. And of course, as Ingrid mentioned, if you've got questions, please let me know, or please use the YouTube chat box on the right there, so we can try to answer them all as we finish the session. So let's start with Kubernetes native. What does that really mean? So if you take a really good look at the CNCF ecosystem, it's incredibly large, right? There is a number of, the ecosystem has just grown so much in the last 5 years since this foundation started when we donated Kubernetes. It's incredibly huge. There is CI/CD tooling, applications, storage, service mesh, API gateway. The list kind of goes on, and it's really hard to take a look at this and figure out how do we do containers? How do we get all these benefits of this increased velocity, and how do we get other benefits of the ability to scale and deploy into different environments very easily? How do we write one application and have it deployed in multiple environments easily? And this is a really tough place to start, right? It's quite a bit of material to sort of understand and go through. So what I often like to do is try to help customers and help folks boil this down into what I think are the most immediate components, right? This is not everything, but it's a really, really good place to start. And I think the things you need to worry about beyond, what I'm showing on the screen here is ultimately incremental. So on the left, it starts with how do we even develop applications, right? What are some of the abstractions we want to sort of nail and land down? How do we package those applications, right? How do we get them out? And then how do we actually manage the configuration? How do we manage these environments and all these objects in a consistent manner that lets us scale our management approach across teams, across different data centers, across different cloud providers? And then on the right, we have the kind of abstractions I think we need to worry about from from a sort of deployment perspective. And if you start at the bottom, right, we're all here because we agree sort of Kubernetes is the right place from a foundational perspective to start. But then as we move up the stack, we realize we need additional capabilities. And I'll talk about why some of those things exist, but we need to have service mesh because it does bring a lot of capabilities that allow us to implement sort of network automation at scale without development teams having to worry about it. We obviously need those policy security guardrails, those controls, so that we can deploy applications in a safe manner. We can maintain things like IT governance and policies there. And if we have compliance or regulatory things we need to worry about, we can also enforce that at that layer. And then obviously at the final bit, we need to be able to deploy applications and services very, very easily. And that's applications of all kinds, whether it's I think, sort of brownfield applications where we're taking legacy things and sort of bringing them into containers in a new way, or maybe we're bridging the gap between virtual machines and containers, but we need a place to actually deploy and run those applications at scale. So when we talk about apps and applications, there's a lot more than just what's sort of externally facing web applications. If anything, if you think about Kubernetes, it's a very sort of generic compute mechanism. It can do quite a bit. It's just we have to take the things that we do today and map them to Kubernetes in an easy way. Now, for sort of web and when external facing applications and services, it's a pretty straightforward pattern, but there's quite a few additional patterns that I think are really important, especially again, as enterprises start to take on Kubernetes workloads. And so one is the operator pattern, right? This is a really important pattern for taking sort of custom applications or custom infrastructure and running it in a Kubernetes environment, right? And what this really does is it gives us the ability to sort of extend the Kubernetes API to manage additional objects, but also let them run in a way that may not be following exactly what the sort of canned approaches are today. So this lets us do things like create new storage infrastructure or have backup and restore mechanisms built into the way we build software, but specific to your applications, and you can run it using the same Kubernetes tooling today. And I'll touch on this a little bit later as we get into it as well. As we talk again about service mesh, things like that, service mesh helps us address a number of challenges, right? Whether there are regulatory or compliance requirements, how we handle things like resiliency and traffic, or things like canary rollouts, or having traffic steering capabilities. Using service mesh is a great way to sort of maintain a good, strong, centralized security posture at that sort of layer 4 and layer 7 sort of level security considerations. And then having sort of turnkey observability is really important, right? These are all things that applications have to do today. And what we do with service mesh is try to take that burden away from application developers and put it on the infrastructure. And it's still the same sort of net amount of work in the grand scheme of things, but it can be done and executed by a much smaller team, and it can be automated a lot more easily. In particular, right, the service mesh we'll touch on a little bit today is Istio, and it has 3 main critical features that we'll again go through in some more depth a little bit later. Uniform observability, right? This is turnkey metrics, logs, and tracing with minimal instrumentation. Operational agility, that basically means advanced traffic controls. And finally, policy-driven security. What that means is built-in out-of-the-box encryption between your services, mutual TLS authentication, and complex and powerful authorization controls. So you can say things like service A can talk to service B can talk to service C, but A can't talk to C. And that's a real simple rule you can put in place to allow to make sure you are not crossing any boundaries you shouldn't be. Now, when we talk about policy and guardrails and things like that, we build on the capabilities of something called Open Policy Agent. Open Policy Agent is a sort of a general purpose sort of policy engine with its own domain-specific language and approach. But what OPA brings to the table that's really compelling is Gatekeeper. Gatekeeper is an integration between Kubernetes and this sort of general purpose policy engine that lets us essentially control whether things can be admitted to the cluster and if we can audit certain things that are already existing within our Kubernetes environments. Now, what that means is you can set up rules and guardrails that say, hey, these applications and services that live in this namespace cannot send egress traffic out. And we can put that rule in place. And if anybody tries to violate that rule, their change is rejected from being admitted to the cluster. That's how we set guardrails, and that's how we do things like compliance and regulatory work in a Kubernetes native environment. And then the last one I want to touch on really quickly is app development, right? App development's a really interesting place from a Kubernetes perspective, because again, I think it's opened the door in a lot of sort of external facing applications, but it's also opened the door for improvements, right? Not just deploying pods and services, but sort of leveling up the challenges around programming and around sort of the operator model. And so for us, we see this kind of approach where serverless has done a really good job of developing this model we think is really compelling for operators and for developers. And we thought a lot about this at Google, like how do we bring this serverless model, right? Some of these aspects, how do we bring those to a Kubernetes environment, right? We want to make sure that we can simplify the infrastructure management. We can provide all the same security controls that Kubernetes environments can have. And we also want to be able to scale up and scale down, right? So only really using resources when we need them. And then from a programming perspective, can we maintain that sort of easy stateless capabilities? We want them to be event-driven and service-based, so they're very sort of small units of functionality. And it should be an open and consistent approach that's portable across different environments. So where we landed here was with a project that we started many years ago called Knative, which itself is not a serverless platform. It's much like Kubernetes. It is a bunch of building blocks. It's a framework for building a serverless approach. So Knative by itself, you can use to build a serverless sort of approach and product and runtime. So that brings us back to our original sort of scope down view of what do we really need to worry about, right? So we had development, packaging, configuration management, apps and services, policy control, service mesh, and Kubernetes kind of on the right there. Now, if we map that to what we know and where we think sort of the Kubernetes native environment's going, what that turns into is our sort of smallest unit of abstraction up on the upper left here are containers. I think we can all agree that that's the right way to go. There's a lot of tooling based around building and deploying containers. This is the right approach. For packaging applications and then ultimately deploying them, I think for very, very custom things, we should rely on something like operators, which we'll get into. For off-the-shelf approaches, we can also rely on things like Helm, and again, we'll cover that in depth. And then I think for configuration management, the sort of principled approach we see taking hold, again, in this ecosystem is around GitOps. We'll talk about that a little bit, and I think this may be a session that we maybe want to revisit and spend a little bit more time getting in some depth on. Now, on the right side, if we look at that stack now, Kubernetes maintains its position there as the foundation. And then we use Istio as a service mesh. We have Open Policy Agent and Gatekeeper as our policy control mechanism. And we use a Knative-based approach for building serverless apps and services on top of this environment. So now let's talk a little bit about the packaging part. Let's start there. So again, when we talk about Kubernetes native workloads, some of the goals or some of the principled approaches here are that we have services over servers. This means we don't want to worry about individual infrastructure underneath. We just want to make sure we're worrying about services and dealing with it at that abstraction or at that level. We want to go for configuration over convention. We want to have things be declarative. We want things to be following a very sort of well-worn configuration approach and not just rely on sort of built-in convention or old approaches. We want to take a step towards automation, right? Instead of having to manipulate objects in flight or after they've been deployed. And we want to treat things as immutable, right? We don't want to have to keep revisiting existing objects. We just want to treat them as once they're deployed, they're immutable. And if we need to, we'll remove them and start again and push a new object. So these are some of the really, again, high-level principled approaches of Kubernetes. Now, when we talk about packaging and distribution and how we get things out, there's obviously different approaches here. CRDs are a very sort of custom approach if you need to map new types to Kubernetes, the Kubernetes API. Operators built on top of CRDs and lets us map new lifecycle events to Kubernetes applications, and again, make them more native to the approach. Helm and Marketplace are approaches to essentially deploying packaged applications or prepackaged applications, depending on what your needs may be. This is really important, and this is where I think I spend a lot of time when we're talking to customers and development teams about Kubernetes and how it's going to fit into their environment. And it really comes down to, what do you know about your workloads, right? What types of applications are you intending to run in this environment? Are we talking about stateless applications or stateful, right? How does the lifecycle of those applications map to Kubernetes lifecycle? Right. And for example, you may have a large scale data processing sort of pipeline you want to build and want to run on top of Kubernetes because it has a lot of good benefits for that. That's great. I think it could be a very good fit. But again, we have to think about how does the lifecycle match up, right? How are jobs started and submitted? How is that pipeline sort of orchestrated from one step to the other? How do we recover if part of the pipeline breaks sort of mid-cycle, right? These are all really important questions to ask yourselves, because how you answer this is going to inform what are some of the workload, or what is the appropriate packaging type, because there are lots of applications that could just be an easy lift into Kubernetes based on, again, that lifecycle is very straightforward. Stateless apps are a good example of this. Stateless applications fit very well into Kubernetes because they can be spun up and thrown away as needed. For stateful applications, it's more complicated. This is where, again, these sort of lifecycle events come into play. But then again, there are other questions you have to ask yourself as well, right? How complicated are the DevOps activities required to maintain these applications, right? Things like, again, backup and restore, restarting, just sort of ongoing maintenance. Those tasks are important to enumerate in order to really provide the right sort of, again, native packaged approach. And then the last question I always ask is are these applications, are these systems part of core infrastructure? Because again, that will help us understand how do we do this work? What's the right packaging strategy? So when we take a look at operators and how that maps into, again, this sort of very native kind of approach, right? Operators can do things like deploying applications on demand, restoring backups, taking and restoring backups of the state of those applications, upgrades. These are really, really important. I think folks forget about upgrades on a regular basis, especially when it comes to stateful systems like database infrastructure or eventing or messaging infrastructure. Those sorts of things can be very complicated, and the operator approach can help sort of do that. And then there's, I think, a number of other things. I think the other one that I think comes up quite a bit is the final point here, which is, distributed applications and having sort of leaders and elections. That stuff, again, can be very complicated, very, very important to your business. So we want to make sure that we map, again, these lifecycle tasks to the appropriate packaging approach, which is why I like operators quite a bit. It is an investment in terms of effort, but the upside is that you can match what you need to do, what your business expects, to Kubernetes very, very well, and make it sort of very maintainable over time. One of the great examples that we can often point to is the Spark Kubernetes operator. This is something that Google Cloud worked on, as well as a number of other industry folks, but particularly for our environments. What it did is it takes the concept of running Spark workloads, which is a large-scale data processing mechanism, or streaming, etc., and runs it on top of Kubernetes. So it becomes a Kubernetes native workload with this operator. And it lets us do things like running Spark submit, so taking those jobs and starting a processing pipeline. It integrates with cron, so it can, with Kubernetes built-in scheduling, to run jobs on a regular schedule. Lets us do things like automatic application restarts and retries. Again, very important for large-scale processing pipelines. And it lets us automate things like mounting Hadoop configuration and data from cloud storage areas. So this is a good example of a complex piece of software that wasn't intended necessarily to be run on Kubernetes, but can be made to by mapping its lifecycle events to an operator approach. Now, when we talk about sort of off-the-shelf software or sort of prepackaged software, Helm is one of the great options that comes to mind. And Helm is not perfect. I think with a lot of the stuff in the cloud native ecosystem, there can be some trade-offs. But Helm's pros, I think, will far outweigh its cons for the most part. It lets you package your applications just like you would, package binaries for inclusion in like a package manager. That we would typically do with something like Linux back in the day. Now you can do the same style of approach with Helm and your Kubernetes-based applications. So it does help with a lot of the same kinds of ideas, but in a slightly more simplistic way. We don't get a lot of the same advanced kind of control over lifecycle events, but if your applications have very stable approaches and that follow Kubernetes API constructs very well, like simple software upgrades, then Helm is a great fit. And there is a huge library of existing work with Helm that you can build on top of. And I think there are some cons, but they don't far outweigh depending on the scenario. I think the biggest one that we find that can be a challenge, and this is more of a cultural thing than a technical problem, is this last con on the right, where you can mix declarative with imperative, right? You can, when you're deploying Helm charts as a packaged approach, you can actually override things that are in those parameterized manifests at deploy time, and that can be dangerous because it's hard to figure out who may have set that parameter, what that value might actually be, and these are the sorts of things we want to make sure we avoid. We want to make sure that in Kubernetes environments, we are as declarative as possible. And the last one I want to touch on really quickly is an example marketplace. Google Cloud runs a huge marketplace for applications that deploy directly into GKE and Kubernetes environments hosted within our platform. We're not going to spend too much time on this, but I just want to say we have a great number of ISV partners. This is, again, a pre-packaged sort of software approach as well. And then this might, again, warrant a further discussion if we've got some time in the future. So now I'm going to pick up the pace a little bit and talk about managing services. This comes up quite a bit. Why do you need a service mesh? And I can sort of simplify here with a little bit of left and right. On the left, we have applications, and those applications need to build in support for things like identity, encryption, tracing, etc. And they've also got to worry about how they're going to handle ingress, access control, and egress. That can put a lot of burden on application teams where, again, if we think about this move to microservices or to many, many application teams, that's a lot of burden you're putting on every single team. The benefit of service mesh is very simple. It takes away those concerns and offloads them into a simple approach with a control plane and a proxy. That proxy is denoted here in this pod example where it's a little icon next to the app. That proxy mediates all inbound and outbound connectivity, network connectivity for the application, and is configured by a central control plane. That same proxy powers ingress and egress mechanisms. So all of the things that we typically have had to either compile in or run separate systems for in the past, using service mesh, we get these things essentially for free, right? Circuit breaking, fault injection, identity support, service-to-service encryption, complete observability, all comes out of essentially controlled control plane with a well-worn API. So this is the right approach for, again, we think for enterprise applications over time. Istio is, again, our approach there. I often will tell customers, that Istio is network automation at scale, right? This lets us do a lot of really good work for services with a very straightforward API. And so Istio has three main areas. We touched on these a little bit earlier. So telemetry, traffic, and security. Telemetry is little to no instrumentation, gives you metrics, logs, and tracing. Traffic controls let you manage and monitor the sort of east-west traffic, so that's within your deployments, and the north-south, which is in and out of your deployments. And then security, again, we talked about this very simply, strong authentication and authorization mechanisms built right in. With observability, we get logs, consistent flow logs and metrics. As I said, we can do things like track SLOs and error budgets, can get a really much better understanding of service dependencies, and we can start to understand how the behavior of our services impacts customer behavior. By default, Istio will actually grab these 6 metrics right out of the box with no work at all. So this already starts to give us a strong idea of the health of our services, the latency, and the availability, which is, again, critically important as we think about not just whether our individual services are up and running, but again, how is the behavior of those services together as a group impacting our customers at the end there. From an operational aspect, we talked about this a little bit as well. Traffic and network controls are really important here. So Istio gives you traffic splitting and steering lets you direct traffic based on things like L7 headers that are built in. So you can say things like, for logged in users coming with this user agent, I want to send them to v2 of my application or service. But again, those very powerful controls. Circuit breaking lets us test for resiliency, lets us maintain our systems and services in a resilient way. Fault injection lets us test those things for resiliency and sort of chaos approaches. And then finally, egress control, sort of self-explanatory in that we can control traffic leaving our environments. Again, very, very important for enterprise applications. And the last one with security, built-in traffic encryption and service authentication and authorization, complex auditing controls, and again, strong access policies that will integrate with identity mechanisms as well. So if you have external identity, we can integrate that with Istio and then use that to control access to applications and services. Excuse me. Istio also goes beyond containers. It also supports mixed deployments where we have services running inside of a Kubernetes environment and services running in virtual machine environments. That means we can actually bridge the gap between these sort of brownfield approaches of taking things that have traditionally been in VMs and slowly migrating them into Kubernetes environments. We can actually run an entire mesh that's made up of VMs and containers. And in fact, you can actually run you can have a service mesh that's almost completely VMs, though you still need to have the control plane running in a Kubernetes environment. That is one requirement. And it also does spread to multiple clusters as well. So we have an approach here, and again, this is a much more deeper topic that we'll have to get through at a later date, but Istio can support multiple clusters spread across different zones or regions, depending on the type of resiliency, the type of deployments, and the services that you may have. But this is all eminently doable with the software today. Now, if we, again, kind of move again further up the stack, we're talking about services and applications and how we develop and deploy those. When we talked about Knative earlier, and we talked about sort of the operator model and the developer model, well, what we often will start with is what are the challenges those two audiences face? Well, for developers, they want to be able to write code and deploy applications quickly. But with Kubernetes, we've actually increased their work on some level, right? They now have to install things like Docker and figure out how to build. They've got to make sure they get their images to the registry. They've got to follow best practices for image naming and tagging, deploying services, figuring out how to expose it to the outside world, and then metrics and monitoring and logging, and then scaling up or down depending on need. So it's quite a bit of work from a developer perspective just to get services up and running in a Kubernetes environment if they're not familiar. And then from an operator perspective, we've got challenges around scheduling, how do we understand lifecycle and health, right? Naming and discovery, making sure that these things are consistent, not just for 1 or 2 or 3 or 4 or 5, but tens or 20 or 50 or 100 applications within an environment. And the list sort of goes on. Storage, logging, identity, right? These are all concerns that we have. So how do we simplify this and give everyone a consistent surface area upon which they can operate? And that's, again, where Knative comes in. And we're not going to spend too much time here at the moment, but ultimately, if you look at the far left and the very bottom, we have an approach that lets us serve developers really well and let them build containers and deploy them very easily, and operators can manage in all the ways they need to from an enterprise perspective. And that's what's really important. With Knative, we can essentially start with any container and deploy this within a matter of seconds. And that's really it. It's just that simple. Now, Knative also supports, as you'd expect, some more advanced functionality like revisions and rollouts, right? Rolling traffic out and phasing it in. So canary rollouts that will start, anywhere from 5%, moving on to 10, 25, et cetera, until they're fully rolled out, or just running multiple revisions of an application, depending on what you're trying to do or test. Knative lets you, again, build and deploy containers very, very quickly, and then, again, scale up and scale down based on incoming requests. So applications can scale all the way down to 0, and then scale up as they need to. And so it gives us that good bit of elasticity that we'd want to have in our production environments. It's not a great fit for every single application, but we think it's a great fit for a lot of applications, and that's really the key takeaway. And the Knative ecosystem is huge and growing, on a regular basis. Obviously, Google is a big part of it, just like we are with Istio, but we have a ton of other partners like Red Hat and IBM, SAP, as well as a long tail of kind of contributions as well. And now what we've done with Knative is we've taken the API and the mechanism, the framework, and we've built 2 products on it. One we call Google Cloud Run, which is a fully managed sort of container to source to container to deploy system for running applications. And then we've also got Google Cloud Run for Anthos. And we'll touch on where this fits in the grand scheme of things. But suffice it to say, the important thing is Knative has a significantly large and growing ecosystem, and we're seeing a lot of interest in applications and deployments that are happening here. So it's a good growing area. Now, I want to finish on a couple of topics, and I'm just doing a quick time check. I think we're doing all right. So I want to talk a little bit about defining and enforcing policies. Again, when we think about enterprise and some of the challenges they have, it's really important that we find the right way to allow security, platform teams, service teams to set up the right guardrails so they're safe, but at the same time, let development teams and application teams run at the pace they need to. So one of the things when we talk about policy management or policies in general is there's often this approach where we need to sort of disambiguate between configuration and policy. Now, configuration very simply is again, how do you store and manage that configuration, right? And the process is typically right in a cloud native environment where we're pushing towards sort of GitOps as a process for configuration management and who can do it. And that's really where like the role-based access control in Kubernetes comes in, right? Who can deploy configuration and how do we manage that? And then config management sort of enforces the state of the deployment or the cluster itself. Policy management is a level up. Policies, again, we talked about this a bit earlier, it's the rules that we can apply to an environment. How do we enforce the rules? How do we apply rules that we take? So again, business rules like disallowing egress traffic or making sure only certain services can talk to each other, enforcing encryption, to be happening in transit. So those policies are really important. Those are business rules that we need to express and make sure they get implemented in the environment. And those policies need to be able to admit or deny objects based on whether they violate or don't violate those policies. So this is the sort of the distinction between configuration and policy. As I mentioned, Open Policy Agents Gatekeeper is what the mechanism is that provides this integration between a policy engine and Kubernetes from an admission control perspective. So if you look at the top and you start this diagram from the top and move to the bottom, a policy is broken up into two parts. There's the rule definition, which we call a constraint template, and then there's the actual enforcement of that rule, which is called a constraint. And what we can do is we can write a single constraint template and then decide how we apply that. Now, for example, you may say, maybe my rule is that encryption in transit must be active for services in a particular namespace. And we may enforce that rule across all the namespaces except for maybe one test namespace or maybe a namespace where we don't have any security critical services running in. So that could be an example of a single rule applied differently across a large deployment. And now that policy goes into the system and we can deliver that policy through APIs, through kubectl, through config management systems, and then we can actually use Gatekeeper and Kubernetes again as an admission review and request mechanism. So if anybody comes in that violates the enforcement or violates the rule, that object does not get admitted to the cluster. We're not going to spend a ton of time on this because it's a little bit in depth here, but the point is this is an example of the rule that we talked about. So this is the sort of documenting the rule structure on the right here. And what this rule is actually doing is it's checking for an Istio object that's basically saying if anyone tries to disable mutual TLS, reject the object. And so this is the rule definition. And then on the next page, we have the kind of enforcement. In this case, we're enforcing this rule and saying deny any objects that might come in that might try to disable MTLS or mutual encryption, mutual authentication encryption, and make sure we're evaluating this on this namespace in particular, the default namespace. So again, this is just one example, and we have a lot more we could spend time on here. So if there are questions, I'm happy to talk through them once we get through the main material here. The important thing is that if someone tries to send an object that violates that rule, it gets rejected, right? This can't come in. So what this is saying is no one can go ahead and then turn off MTLS or the encryption in transit. And that's a really important point. And this is just one very, very simple example, right? If you think about this in a larger way, there are a number of other examples here that are really important, right? We may want to have fine-grained service controls. We may require that logging and metrics be activated for a particular cluster. We may want to disable any unauthorized access. These are all incredibly important things for enterprise applications, and we need to make sure not only are they happening, but that those things can't be changed, right? That we strongly enforce this capability from a security perspective. So this is really important for us. So now if we take a step back for a second, we talked about a lot. We covered a lot of ground, right? We talked about sort of the abstraction layer from an application development perspective, some of the abstractions around packaging enterprise workloads. So going beyond some of the sort of straightforward and obvious sort of stateless applications or web applications and talking about how do we package enterprise workloads in a Kubernetes way. How do we do config management? And again, at a high level, right? We touched briefly on this idea of GitOps. And again, that's another topic we should spend some significant amount of time on from a management perspective. But again, it's the way we see the ecosystem sort of trending as well. And then we talked about the state of deployments, right? Going from the bottom up, we talked about Kubernetes, service mesh, implementing policy control, and again, that serverless style approach applied to Kubernetes applications and services. Now, one of the things that we've seen over the last, or among the things we've seen over the last several years, having initially developed Kubernetes, having driven the development of Istio and Knative, was this strong pull for hybrid and multi-cloud solutions, right? A lot of folks were telling us they really liked our opinionated approach around this entire stack that we talked about, and they were asking us, how do we get this same thing running in hybrid and multi-cloud environments? But again, keeping all the same tools that we care about and that we love so much. And so some of the challenges that we heard on a regular basis were, how do we operate sort of multiple environments, right? Kubernetes, again, is a solid foundation, but there's so much more than just Kubernetes that needs to live and be orchestrated in an easy and sort of unified fashion. So having multiple Kubernetes environments was still leading to some inconsistencies around things like configuration or deployment mechanisms, et cetera. We also needed, I think, a stronger interoperability. This is what we're hearing from customers, that needed stronger interoperability around legacy workloads. And how do they bring those legacy workloads into these new environments? How do they modernize them in place? How do they create a path to, potentially cloud environments as well? We've also heard, from customers as well about things like developer velocity, but making sure that we can maintain their pace while also making sure that they're complying with security policy. So again, there's a lot here that we heard from customers. And we took this to heart. We wanted to figure out a way where we can get our approach sort of filtered out back across the rest of the ecosystem. And that's where we came up with Anthos. That's where we landed. Anthos is a lot of things. I think it can be a complicated topic to go through, but let me simplify it for you. It is an opinionated approach to running hybrid and multi-cloud applications and services, right? That's the best way to put it. And there's a whole bunch of tools. There's a whole bunch that is involved in Anthos. But the important takeaway is that we are going for a consistency of software across multiple environments, cloud, on-prem, other clouds, soon edge as well. And we're applying a consistent set of software and tooling above that. So what we want to have is a unified approach to management, a unified approach to services and service mesh, unified way to deploy applications, and by the way, not just deploy applications, but also do things like ingress across multiple environments and multiple clusters, as well as a same kind of consistent, strong sort of serverless model and application model, and a long tail of other tools, including the ability to migrate VMs and turn them right into containers, right? Legacy workloads that maybe aren't being maintained anymore, turn those right into containers. So there's a whole bunch on Anthos, and I would love to spend more time talking to all of you about Anthos. So hopefully, maybe we can schedule another event here later in the future about particularly around Anthos and our approach in this way. But I want to talk a little bit about some of the core components of Anthos, and then I want to open it up for questions. Core to Anthos, and I think one of the most important aspects is that Anthos is built from open source, built on top of open source. So much so that Anthos has a Kubernetes distribution called Anthos GKE, Google Kubernetes Engine, which is fully Kubernetes compliant, right? We're building right on top of Istio, and we're leveraging all of Istio's APIs and capabilities into something called Anthos Service Mesh. And we're taking Knative and that framework, and we're turning it into Cloud Run for Anthos, which I mentioned a little bit earlier. And it's bringing all those same tools and capabilities, but in a managed, again, unified, centrally sort of managed approach, and in a way that gives us an order of magnitude sort of more tooling and capability on top of them. And so we dig into this a little bit. So with Anthos Service Mesh, which is built on top of Istio, right, using Istio's APIs and Istio's capabilities, obviously we get the same sort of observability mechanisms that Istio provides, like consistent flow logs and metrics. But we actually get a chance to go a level deeper, and I touched on some of these a little bit earlier. We get to, right out of the box, understand service dependencies in a way that we couldn't before, right? So you can see this picture on the left here. This is just by deploying an application without any changes into an environment, into the service mesh, with Istio enabled, with Anthos Service Mesh enabled and activated, we can actually suddenly understand service dependencies very quickly, and we can also get an understanding of service health through things like SLOs and using latency or availability indicators and metrics. So what that means is we now have the ability to, in a very turnkey fashion, deploy applications with little to no change whatsoever, make them part of Anthos Service Mesh or part of the mesh, and now get a deeper understanding of service health, not just, again, individual metrics, but in a way that lets us understand how is the behavior of my services impacting my customers, right? If you combine the dependency graph on the left here, along with the SLOs on the right, what we'll actually get to is this view of saying, well, now I can get a sense for how my entire application is performing and what its behavior is, right? I can see latency in one component that may be cascading and having a latency impact on a whole bunch of other services because of, again, that dependency graph. And we can apply SRE approaches and start to understanding, well, how much am I violating the SLOs I may have set with my customers, right? If I guarantee to them that 99% of all their requests will happen within, less than a second of latency, less than 1,000 milliseconds, how am I doing on that guarantee I'm offering to my end customers, right? Am I able to maintain that? Are we out of error budget for the year or for the time window we've established? So these are really important ideas. And again, this is Google applying their knowledge and experience around running services at scale, and again, understanding customer impact and the behavior of applications as they impact customers, and being able to provide that tooling back to enterprises. So we think this is a really, really critical additional capability that we package on top of Istio as part of Anthos Service Mesh. And then there's a whole list of other things that I can tell you about as well. In particular, one of the key distinctions between Anthos Service Mesh and Istio is this idea of running a control plane. You might remember me mentioning earlier that Service Mesh relies on a control plane and that sort of application proxy. Well, with Anthos Service Mesh, we actually take out that control plane entirely and make it a set of fully managed components that are running, that we maintain SLOs for. So we're actually going to be able to guarantee you and say the control plane for Anthos Service Mesh is fully managed by Google and is running in essentially controlled way, so that you don't have to worry about maintaining that other piece of infrastructure. So again, these are some of the things that we're doing in this area with Anthos Service Mesh. And then from a management perspective, again, unified command and control and management. So obviously there's a user interface and console aspect to this where you can view all of your clusters, not just the ones within GCP, but all the ones that are running in different cloud environments or on-prem. You can see those, manage those, understand the workloads that are being deployed there, view metrics and monitoring for all those clusters. But from a config management perspective, we also needed a way to say there is a declarative management mechanism that we can use that uses best practices like GitOps and lets us manage the entirety of those environments from a single repository. So that's where Anthos config management comes in. It gives us the ability to take a well-known approach, which is Git, and use it as a source control for managing all of the declarative sort of cluster and configuration state we need to worry about, but doing that from as source control. And it lets us do things like apply policies directed to individual environments, right? So we can say, hey, we may have a set of rules and policies and approaches we might want to have for our deployments that are running in cloud environments. And those are distinct from the requirements that are running in our on-prem environments, right? But again, we have a central management tool that can deploy configuration to all of these environments and get very, very specific about how it gets applied. So we have a lot of fine-tuning we can do here as well. Now, the nice thing about Anthos config management is that it's also watching for cluster drift. So if anybody were to go to a specific environment and say, hey, I'm going to make a change in the on-prem setup, we'll actually be able to check for that about every 15 seconds, and I think it's configurable down closer to 5. But every 15 seconds, we'll go back and say, hey, this is the state of the cluster configuration, match the state of what's in our configuration management tool, and if not, it'll reconcile that and make sure it's back to what we've previously defined coming out of Git. So this is a really, really important mechanism. Again, the console and the UI is nice to have, but from a configuration management structure, ACM does quite a bit. And ACM is actually packages Gatekeeper that we talked about earlier. It incorporates Gatekeeper functionality and Gatekeeper itself as part of its mechanism. So all the same things you heard about policies and guardrails and security can also come out of Anthos config management. And I think the most important aspect here, and this is one that I touch on quite a bit, is that ACM allows us to treat the state of our deployments, the state of our clusters, as software releases. So all the things you can do with source control and software releasing, like branching, merging, versioning, auditing changes, rolling back commits, those are all things we can do with Anthos config management, which make it a very powerful mechanism. And with that versioned approach, we can actually say the state of our deployments, reach a certain version, and we can stamp it and say we can always roll back to this well-known version in case anybody introduces any problems at some point in the future. So again, it's not the most sort of visually exciting aspect of Anthos, but it's, I think, a critically important and very capable component there. And then last but not least, Cloud Run for Anthos. This is, again, built on top of Knative. We talked about this a little bit in depth as well. The benefit here is that we can, again, scale workloads in very much a serverless fashion up and down as needed, using a straightforward development model and a straightforward operations model. And it lets us, again, build on top of the investment that you've already made in Kubernetes and add these serverless kind of development capabilities right on top of that, while still maintaining all the same Kubernetes-based tooling and ecosystem around management, control, policy, etc. And if you have custom workloads or custom nodes that maybe have things like GPUs in them, or if you have custom networking requirements, like you're running within very tightly controlled VPCs, Cloud Run for Anthos lets us bring, again, serverless capabilities and development to those environments as well. So it does all the same things that we would like it to do, but in these tighter, controlled, and constrained environments. That's everything I really wanted to cover today. So we've touched on a lot of things. I would love to hear questions from all of you. If possible, we'll go back through the live chat. And I would say there's a feedback form you can help fill out for us and let us know what you thought of the session. We'd love to know more about what kinds of things you're working on, what challenges you're running into, and if there's areas you want us to go back through in a deeper way, right? We could schedule this further out in advance and maybe spend more time on things like Knative and Cloud Run, or on Istio and Anthos Service Mesh, on Anthos config management, or just on Anthos in particular. There's a lot we can talk about, but I think this field is wide open, right, for bringing enterprise workloads to Kubernetes-based environments. So with that, let's switch to questions.
Yes, thank you, Sandeep. So we do have one question on live stream, as well as two questions I posted on the Meet. So we start with Joaquin Morea. So maybe I can address that one, because you today have a dedicated Google account team, and the team will be very happy to share with you the slides. I know the recording for some reason, but we definitely make sure that, Joaquin, you have the access to all the data today. Thank you very much. So the second question is from Mathieu Audin.
Yeah, I see this. So the question was, what's the sort of value between Istio compared to Console and Linkerd? Generally speaking, they're all service mesh technology. So I think what ultimately ends up happening is then it's a question of which features are sort of most compelling. And I also think there's, to some degree, when you're talking about open source, I also put a lot of value in terms of how long has this tool been around, how long has it been maintained, who's participating in the ecosystem. And without sounding sort of silly, I think a fair amount of this is also who's building commercial offerings on some of these tools and these technologies. In that way, Istio has, I think, a little bit more of a runway going in terms of the number of enterprises that are adopting it, the number of production deployments, as well as the number of companies that are building on top of Istio and building Istio-based offerings. So I think that's one aspect of the distinction. I do think a lot of it just comes down to sort of API and approach. I think if you have an existing console footprint, it may be easier to adopt something like Envoy and incorporate that as part of your console deployment. Now, I think the distinction starts to come into, again, what does the ecosystem look like, right? How do we do things like some of the SLO capabilities, or how do we do the observability capabilities that Istio and Anthos Service Mesh in particular bring. And that may be, again, where you see some distinction. But I would say there's a wealth of information out there. It's very quick and easy to kind of start with all three of these tools. I would find the API that fits best. And then again, look at that long-term roadmap, look at that long-term footprint and usage, and let that kind of help guide your decision. The next question I see in the chat is, does Cloud Run work in an on-prem cluster? If you are using Anthos and you have Anthos deployed on-prem, Cloud Run for Anthos is a supported deployment in an on-prem environment. So you can absolutely bring Cloud Run to those environments. From a testing perspective, if you wanted to get a feel for how this might look and function, you could certainly run Kubernetes in an on-prem environment and then deploy Knative to that cluster and get a feel for some of the serverless aspects. It's not quite as sort of frictionless as I think Cloud Run is, but again, you'll see those building blocks in action with Knative. But yes, to answer that question, Cloud Run does work in Anthos on-prem deployments. The next question I see from Derek is, excuse me, do external services not hosted in Kubernetes have the ability to have policies applied with Anthos if they are stateful like databases? So the question there is, basically, can we adopt the sort of policy approach for applications that might be running outside of a Kubernetes environment, but that may still be part of Anthos? And the answer is kind of, right? It's not a complete 100% yes or no. It depends on the way in which we brought that application in. So if you use something what we call mesh expansion and you bring VM-based software into your service mesh, there are certain things that we can apply policy around, but not everything, right? Because there are maybe Kubernetes-based policies that we want to use, but it's not running in a Kubernetes environment, right? It's running in a VM, so that may be different. But because it's part of the service mesh, any of the service mesh capabilities can be governed and controlled by the policy mechanism. So it ultimately depends on what you need managed. Now, again, for like things like database infrastructure that are running, you could certainly apply some things like, hey, we want to make sure all of our applications use mutual TLS encryption and authentication when communicating with this database. That's absolutely something we should be able to enforce given mesh expansion and policy controls. The next question is, how do you evaluate whether your working environment is at the point where it is worth the trouble of all the configuration and maintenance that comes with using Kubernetes? That's a great question, and we're probably not going to have enough time, I apologize, to answer that in a couple minutes. It's tough because it really depends, right? Like, I think Kubernetes is a very compelling piece of technology, but it brings management concerns and considerations and overhead. So you have to sort of look and see how much time are we spending worrying about infrastructure. And I don't mean infrastructure in a generic way. I mean, like, how much time are we worrying about spending software running on computers and those computers dying and having to rerun software or have to do complex DevOps work to respawn applications and make sure they're running? Or how do we find consistent approaches in terms of deploying software and packaging things, right? These are the sorts of questions you have to ask. It's not even about sort of the application code itself. It's about all the tasks that have to happen to make that thing run and run in the face of operational challenges, resiliency issues. If you find that there's a lot there, it's maybe worth considering, because there's a learning curve to Kubernetes and I think even to Anthos, to a fair amount, but the benefits could potentially outweigh it if you have now a well-worn path. There's a huge ecosystem of tools, software, and people who understand it, and it adds a level of consistency around DevOps activities and lifecycle activities that you didn't have before. So I think that may be where that benefit is. And where that line is depends on your organization and your expertise, but it's certainly something to compare. Another question here is, what are the available certifications and exams for Anthos? That is a great question. I don't have an answer for that, so I'm hoping maybe Ingrid or the account team can help answer that one.
Sorry, regarding certification?
Yeah, what are the certification options and exams available for Anthos
today? I will make sure that the team is coming back to you with a guidance on how to certify on the platform.
Great, awesome. Thanks, Ingrid. The next question was, how is ACM compared to Terraform? They do different things, right? So Terraform is about laying out the infrastructure, right? So essentially configuring the software that's going to run on a fleet of VMs or a fleet of hardware infrastructure. ACM is more about managing the Kubernetes aspects. So once Kubernetes is deployed, you can actually use ACM, Anthos Config Management, to say, hey, let me back up and zoom out for a second, but in a lot of deployments, we see multi-tenant approaches where instead of running a bunch of small Kubernetes clusters, which can introduce overhead and add time and management, we see folks running large Kubernetes deployments and then deploying applications from multiple teams in that same environment. And what they do to partition those environments to partition that large multi-tenant approach is use namespaces. Namespaces provide a good logical boundary between applications and in between teams. And those namespaces can actually have quota requirements, configuration requirements. You can actually implement a whole bunch of control using namespaces as a boundary. Now, what ACM does is it lets you, from a centrally controlled approach, implement that sort of command and control of that partitioning or those namespaces in a very easy way. Now, so for example, you could say, hey, I have 3 teams. They all work in maybe the same application, but each runs different services. They want to have 3 namespaces, but we know they're going to have the same quota. They're going to have the same resource control. They're going to have the same secrets and configuration applied. Well, with ACM, because it's based on Git, it's a very much a file and folder structure. You can actually create one abstract namespace that contains all 3 of those, and it actually pushes that config out to all 3 of those namespaces. And this is I'm explaining more than I probably can do with just words, and we'll have to get some slides. But I think it sounds like from the questions, an Anthos session may be worthwhile. One of the next questions was around seeing an Anthos session where we can manage kind of GCP and on-prem in one view. And I would love to do that. I think that'd be a great demo we could do for 45 minutes to an hour.
Absolutely. I will work on that and schedule that for the next lunch and learn. Thank you very much for the feedback. We value your feedback. Thank you.
We're running up on time, so I'll be sensitive to it, but I'm going to try to get to this last one here. So what kind of GitOps tools would you typically give advice to use? Argo, Flux, or would you recommend use Helm versus Customize? So this is probably a philosophical debate on some level in terms of like tabs versus spaces. The good news with Argo and Flux is that they've actually merged, as far as I know, and it has become the sort of top-level Argo project in the CNCF. So that's a unified effort now, which is great. And then the question is sort of Helm versus Customize. So let me go back to the GitOps for a second. So there's 2 parts to GitOps. There's the configuration aspect, which we solve with Anthos Config Management. But then there's the application aspect. And I think that's a little bit more up to the environments and the teams that you're working with. So I think Argo is a great fit. We've seen a lot of customers use that. We've also seen folks use the built-in tooling into things like GitLab or even GitHub Actions, using Cloud Build or Spinnaker as ways to deploy services in. I would say Argo is a great place to start digging in. If you're looking for an option between those 2. Now, Helm versus Customize, again, gets a little bit more specific. I tend to like the approach of having applications have 2 repos. One is the source and the sort of like the base manifests, and then a second repo that actually includes the things that are deployed into staging, development, or production environments. And so if that's your approach, I think Customize is a pretty good fit. Helm can do the same thing, but I think the part with Helm is that you never deploy Helm with any imperative values, and you also find a way to store the Helm chart that you're going to deploy so that you can always roll back to a known good state. So again, you could follow the same approach of saying, I have my Helm chart in one repo, and then I have a separate repo of what's actually deployed and pushed into my cluster using a GitOps tool like Argo. We're at time, so again, I want to be respectful of everyone's time here. Is there a good way for us to take the questions offline, maybe follow up with folks after?
Yes. I'm going to offer an opportunity. I see that there's a lot of questions, and thank you very much. We love your engagement and all the questions. So I hope this session was helpful to understand Kubernetes and how it can fit your organization. This session are every week at the same time, different topic. For instance, next week, we are welcoming our customer in order to talk about Google Meet. 2 weeks from now, we have a session on with 2 engineers, site reliability, joining us, Cindy Quach and Betsy Bayer, to have a conversation around SRE. I took notes today about an Anthos session as well as a cloud build session that is a big interest. So we are going after this call to share and send a note and a registration link for the next session. And definitely, we also are going to ask you for feedback. We value your feedback. Thanks to you, we are becoming a better organization and we are serving you better. So thank you very much for making the time for Google Cloud, and we'll definitely be in touch. You do, as I said earlier, have a dedicated account team. We are really eager to share best practice, engage more with our customers. So thank you very much. Stay safe and healthy, and we'll talk to you very soon. Have a wonderful day.
Thank you.
Thank you.